Okay, today's exercise, factorising polynomials, and so it kind of leads on from the last one. So we know how to divide things, and so whether we use the long division method or the synthetic division, doesn't matter. We know how to divide things, so we can find factors if we need to by dividing out. But there's a bit of trial and error, and the long division and the synthetic division, they take a bit of time. So it'd be good if we had a pattern that existed that we could use to help us to shortcut a bit of time. Because maths is about patterns, and so if we can find a pattern which shortens the amount of work for us to do, then that's great. And so in the last video, one of the examples was this: 3x cubed plus x take 3, and we wanted to divide that by x take 2. So what we did is we set it up, and we said, all right, we're dividing by x plus 2. We've got 3x cubed here. So that I don't lose track of things, I put in a 0x squared term. Plus x take 3. And then in the end, after all of that work, whether this is the long division setup or whether you did the synthetic, you find you've got a remainder of 23. But what I'm going to do is I'm going to take this and have a look at this. And I can say, all right, what does x have to be for x minus 2 to be equal to 0? And x would have to be equal to 2. And so we go, all right, okay. So let me call this bit at the front, let me call that polynomial p of x. And then it's 3x cubed plus x minus 3. We'll go, all right, so let's put this x value, 2, in here and see what's going on. So p of 2. So that's 3 times 2 cubed plus 2 minus 3. So that's 3 times 8. Plus 2 minus 3 is minus 1. 3 8s are 24, minus 1. 24 minus 1 equals 23. All right, so here when we did our long division or synthetic division, we got a remainder of 23. And here, when we put x equals 2 in, which is related to what we're dividing by, we get a remainder of 20, or a number of 23. So those two things are the same. And so if you check that with more stuff, so like, for example, x cubed plus x squared minus 14x minus 24, divide that by x plus 2. And last lesson, in the last video, we found that the remainder of this was 0. So here, if I'm looking at what does the x value of x have to be for x plus 2 to be equal to 0, well, of course, it's got to be minus 2. And so if that's p of x, so p of minus 2 would be minus 2 cubed plus minus 2 squared minus 14 times minus 2 minus 24. So minus 8 plus 4 plus 28 minus 24. So we've got minus 8 and minus 24, which is minus 32, plus 4 and plus 28, which is plus 32, which is 0. So you see again, we're getting a number that's the same as the remainder. So that pattern, if you try more and more and more stuff, that pattern applies. And so that pattern is what's called the remainder theorem. All right, the remainder theorem. And so this is this is a mathematical way of writing it. So if Px is divided by beta x plus alpha, where beta and alpha are numbers, then the remainder is given by P of minus alpha on beta. Now I know I'm going to get people saying, some people questioning where'd you get this here from? Remember back up here I was saying, taking that and I was saying, when does that equal to 0? What's the x? So if I look here at this, and I'll do it over here, beta x plus alpha, when's that equal to 0? Take alpha from both sides. So beta x is negative alpha. Divide by beta both sides. So x is equal to negative alpha on beta. All right, and so that's the number that's in there, because they're numbers. So let's do an example of one where there is. So I'm going to do this example, P of x. Ooh, it was nice of that to jump there like that. All right, P of x is x cubed minus 2x plus 4, and I want to divide it by 2x plus 1. So remember, we're looking at where 2x plus 1 is equal to 0. Take 1 from both sides. So we're looking at 2x to be minus 1, divide by 2. So we're looking for x to be negative a half. So what I'm going to do to find the remainder, I'm going to go P of negative a half. And so negative a half cubed minus 2 times negative a half plus 4. So negative a half cubed is negative 1/8. 2 times negative a half, negative times a negative's plus 2 times half of 1 plus 4. And so that is negative 1/8 plus 5. Oh, all right, 5 is 5 over 1. So to write 5 over 1, whoops, got ahead of myself there. 5 over 1 is 8ths. Top and bottom here by 8. 5 8ths are 40. And so we've got minus 1/8 plus 48ths is 39/8 as our remainder. All right. Then when we go back to an example that I had before, this one here, where the remainder was 0. So when the remainder is 0, a particular thing is happens. So say, for example, I wanted to do 6 divided by 4. That goes in once, and then I've got a remainder, all right, of 2/4, or a remainder of a half, all right. But if I go 6 divided by 3, that goes in evenly. It goes in twice with a remainder of 0. So this number 3 we give it a particular name in terms of the 6. What we say is it's a factor of 6 because it goes in evenly, because it has a remainder of 0. So if we use the same idea, remember maths is about patterns and maths very rarely has exceptions. So if here we say that 3 is a factor of 6 because when we divide it in it goes evenly and there's a remainder of 0, we can use the same up here. So when we divide x cubed plus x squared minus 14x minus 24 by x plus 2, we get a remainder of 0. So what we could then say is that x plus 2 is a factor of that particular polynomial. And that's what we call the factor theorem. All right, so the factor theorem is related very closely to the remainder theorem. In fact, it's kind of a subset of the remainder theorem. Find the remainder. If the remainder is 0, then what you've divided it by is a factor. All right, so the factor theorem says this mathematically, it says this. Let me have a look at it. It says for p of x, if p of a equals 0, then x minus a is a factor. All right, and so that's the basic form of it. So an example might be this. Example, show x minus 1 is, factor of this polynomial px equals, let me write it down properly, transcribe it correctly, otherwise that would be very embarrassing because it wouldn't work out, plus x plus 6. All right, so if x minus 1 is a factor, we've got to show it, then when we divide it, the remainder has got to be 0. So we're taking this x minus 1 and we go, okay, so for this x minus 1 to be equal to 0, x has got to be equal to 1. So if x minus 1 is a factor, then p of 1 has got to equal 0. So let's have a look. P of 1 equals 1 cubed minus 4 times 1 squared plus 1 plus 6. Oh, see, I said transcribe. I've transcribed it incorrectly. It should be showing x plus 1 is a factor. Oh, so let's just see, I said that was embarrassing and I transcribed the first bit incorrectly. And it is embarrassing because now I've got to go through and I've got to do all this. And you're all sitting there going, Synno, what are you doing? I'm going to claim I'm getting old. All right, after all of that, sorry about that. All right, let me just check the polynomial I've got. Yeah, I do have that bit right. So I've got the simple bit at the start wrong. All right, so -1 cubed is -1. Negative 1 squared is 1. 1 times 4, negative 4 is negative 4. Plus negative 1, which is minus 1. So I don't need to write plus negative 1. I can just write negative 1 plus 6. And then that, of course, is 0. So x plus 1 is the factor, not what I had written originally. So I hope I haven't confused you by that. That is very annoying. So if we take that a little bit further, and say, oh, I want to now factorise. So if we continue with that, to continue, no, I'm not going to write that. We can then use this to help us factorise, which is what the whole point of the thing. All right, because now we know that x plus 1 is a factor. All right, so what we could then do is we can go, all right, if x plus 1 is a factor, let's use some synthetic division. I need to make my box quite that big, but anyway. All right, so inside here we're going to have the coefficients of those terms, and the x cubed term had a coefficient of 1. The x squared minus 4, plus 1 for the x term, and then the constant on the end was 6. All right, so that's from here. And we put p of 1 in there, and that's what goes out here. Sorry, that should be p of minus 1 there. Forgot to change that bit. All right, and so that's what goes in here, minus 1. All right, which relates to our x plus 1, and it's x equals 1. All right, bring the 1 down. Minus 1 times 1 is minus 1. That plus that's minus 5. Minus times a minus is a plus 5. 6 minus 1 times 6, 0. The remainder, beautiful. So what that means then is that means that x cubed minus 4x squared plus 6x plus x plus 6, I should say, is the same as x plus 1, which was one factor, and we've now found another factor. This is our x squared coefficient, minus 5x plus 6. Now we've reduced this to now a quadratic, and this quadratic we can, two numbers that multiply by 6 to 6 and give us a 5 as when we add them. I reckon is minus 3 and minus 2. And so there it is. Even though we weren't asked, we were just asked to show x minus 1 as a factor of that. We can then continue and go further and fully factorise it. All right, now what are we looking at? The next bit here. Got some more, the next bit. All right. So here's one that's a little bit more tricky. No, let's not do that. That's a bit too tricky to start with. We need to have a look at factorising something else. Easier before I do that one, I reckon. Right. Sorry, I'm fluffing around here, aren't I? All right, so sorry, I'm going to pause and then find a good example and then come back in.